Good morning, good afternoon, wherever you may be, and thanks for joining us today. Hopefully you take away some more knowledge than you came in with about the relatively new ULC S576 standard for products and how TOA has responded to this standard with some of our products, notably the VM3000. We'll take a look at what we're going to cover off. We'll do a very brief history of the TOA Corporation and how we respond to the emergency communication and mass notification products. We've done some other webinars on mass notification, and if you'd like to view those, contact us and we can get the links to you. They would be a little more detailed than what I'm going to go through today because we've covered this off quite a few times. So we'll go over a little bit of history and why emergency communication systems and mass notification systems, why they are a topic for today. It's a very hot topic right now. And we'll look at the impact that the relatively new, it was released in 2014 in September, the ULC S576 standard for products that are used in emergency communication systems. We'll look at how the TOA's VM3000 can address these standards and some of the applications that are suitable for the VM3000 and also some typical configuration examples. A very brief history. Obviously, mass notification is not something that's new. It's been going on ever since civilization started. It's definitely a means to communicate. In the past, it was a very simple communication, and then it's progressed over time. And you can see that the talisman or the monument there, that it's just a very simple marker to warn people not to. In this case, it was building below a certain elevation because of tsunamis and things like that. So a very early start for mass notifications. And then those big horns, that's actually a TOA development that happened many years ago in trying to communicate in a more wide area approach to impending disasters through hurricanes and tsunamis and volcanoes and what have you. So you can see we've been in the process of developing mass notification systems for many years, and that those horns have developed into the newer standard, the HA450 high-powered speaker array just to the right of those horns. That is a new product that is available to us now. And as a manufacturer, we've been in the business for 80 years, and we've been dealing with emergency communication systems for well over 50 years. We were the first in Europe with the EN54 standard, and we're the first in North America to meet the new UL certification in the U.S., which is under the UL 2572, and up in Canada, UL S576. So you can see we provide a broad range of products. The one of concern today is the VM3000. So exactly what is emergency communication systems and M&S systems? Well, basically, mass notification is many layers of technology used to warn of an immediate issue or pending issues. And emergency communication systems is the bits and pieces that make up the mass notification system. So it's the many parts that make up the layers of a mass notification system. And so in the past, basically, the communication systems were there to save lives, and some of the influences years ago, up until recent times, we were dealing basically with weather conditions, etc. In Asian countries. This has been more of a concern than over here in North America, but as you know, climate has changed. We are now having to deal with tornadoes and floods, etc. On a much more frequent basis, and of course with 9/11 happening, that's when it really started to kick in North America, when we realized that we needed to do a much better job of protecting the population. So those are the drivers from the past, and now you can see we're still out to save lives, but now we're into property and commerce. Weather is still definitely an issue here, but we have other issues globally around the world, military issues, the corporate safety, health issues to the public, terrorist attacks, intrusion alerts, Amber Alerts, etc. And two of the drivers that we see here in Canada appear to be more weather and school safety. With the schools, it's basically trying to present a safe environment for the students. Schools are a business, so it's viable for them to provide a safe working environment. So it's a bit of a marketing ploy there. So you can see that there are many more influences today than in the past when we deal with the systems required for emergency communications. So the technology strategy for mass notification is protecting inside a building, outside, and at your side. It doesn't necessarily have to happen in that particular order, but certainly inside a building, you're going to have some communication structure, some notification capabilities to warn people to either hold in place or get out of the building, whatever. And TOA, we are involved in the PA intercom side. When we get to the outside, once you get people out of the building, you want to manage them to get away from the building, go to a certain area, go to a certain direction. Might also be a case where the event actually starts outside, and you want to warn people to stay away from the exterior of the facility. So we get into the high-powered speaker arrays and the paging horns and things like that. And as we get further away from the epicenter of the problem, we have typical technology, cell phones, laptops, pop-ups, email, etc. And this is considered at-your-side technology to basically warn people not to come into an area, maybe direct them away from a hazardous situation. So that is the basic strategy for mass notification. So within the mass notification, we have the stakeholders and decision makers, and they have to come up with the reasons for employing the mass notification. And there's lots of pressures on administrations to come up with a proper plan. It may be based on past experiences, as an example, shooters in that Virginia Tech in the U.S., up here in Canada, we've had the same situation. We may be looking at liability concerns. The lawyers may be involved here, thinking that it's much better to spend the money now rather than paying out liabilities because we didn't do anything to protect the people in the building. Currently now, as I said before, one of the drivers is the school market, and that is the traditional mission to provide a safe work and learning and living environment, where the schools are really operating as a business, and it's a feature that they can offer the students and their parents that if they have a system in place, we can, or they can, better protect them. So the administration is faced with making the decision to deploy an M&S system. So what they're going to do is they're going to do a risk assessment, and the risk is based on probability and impact. And probability basically are these random events or hostile events or things that could possibly happen, and then that's magnified by the impact that's going to have should these events occur. And of course, the financial loss, and to the point where they may actually go right out of business if the event is allowed to escalate and impact on the business at hand. And also protecting the value of the brand. That gets back to the school. We want to provide a safe environment. If a situation happens and you have not employed some sort of protection system as an emergency communication system, then this can affect the brand. So probability times the impact is all part of evaluating that risk. And this must be done by the administration staff coming up with a plan to deploy emergency communications. So who's really in charge here? Basically, once they come up with a plan, they have to put somebody in charge, and it depends on what type of facility it is. If it's a public building, a private facility, a government facility, they're going to have different AHJs, authorities having jurisdiction. And these people will make sure that whatever methods are put in place, that they will determine what is necessary based on the stakeholders' requirements to make sure that the best practices are put in place. Now, of course, these situations right now with deploying mass notification systems, there's nothing encoded in law currently here in Canada. In the States, they do respond to NFPA 72, Chapter 25, and some of those requirements are part of their coding down there. Up here, our building code hasn't caught up with this, the new situation here with products that are coming on stream for emergency communication systems. So we're a little bit behind at this point in time. However, so the AHJ is now going to be in charge of deciding whether certain capabilities are necessary to mitigate the risk factor. So certainly a small community in a remote location may not need all the bells and whistles that a large metropolitan center might need, and so they would certainly waive off some of the more sophisticated approaches to the method of deployment. So as I said earlier on, mass notification is many layers, and it's built up on basically 4 layers. And if we look at a typical onion, it has layers. And the first layer is the epicenter of where the problem or the issue is happening is layer 1. And for these occupants of the building or outside the building or whatever, they are immediately going to be alerted through voice communications or alarm communications to evacuate the building or hold in place, seek safe shelter or whatever. But there's going to be some sort of PA system in here that's going to make a voice communication to the occupants, because it was found that the best way to save lives is to actually have voice instructions. We learned from past events that just listening to bells, etc., did not really do the job that was necessary in order to get people safely out of the building. It has to be much more coordinated, and we can do that through a live voice communication. So that's where one-way voice PA systems come into place. There's also two-way voice communication, because there might be a situation where people need to hunker down into a safe area. I can think of possibly in a situation where there is a chemical spill, maybe a manufacturing that has or handling dangerous chemicals. They may have a safe haven where it's ventilated externally to the outside. They have hunkered down. Mining comes to mind as another example of a safe haven. And they may hunker down and they need to communicate back to the responders that they are safe or where they are or what the situation is. So two-way communication does come into play. Now, obviously, signaling, strobing, etc., and textual signage, messaging to alert people of what the status of the situation is. So all of these technologies come into play at the level 1, at the epicenter of the problem. Then when we get to layer 2, we get to the exterior of the building, and that becomes more of a wide area mass notification situation. And so we're going to deploy high-powered speaker arrays to the exterior of the building. They don't necessarily have to be of this nature. They could be simply paging horns around the exterior of the building. As long as there's good coverage, then that could be considered an exterior or layer 2 protection. Something even as simple as a megaphone. It's portable, it's outside the building. You want to marshal people into safe areas. We do a head count and make sure everybody's safe. And maybe even direct them in an opposite direction should there be some sort of intruder situation. You might want people to go west instead of east because that's where the problem's coming from. So there's all kinds of situations that would come into play when we have PA systems that are directing traffic outside. When we get into layer 3, people are more distant from the epicenter, from the problem, and it may be a case where you don't want people to come into that problem area. Best to stay at home, go somewhere else. We don't want people to come into the area where the issue is actually happening. So now we get into these other services, email, computer pop-ups, smartphone applications, and also third-party applications that may oversee the whole technology that's coming into play. There's a few companies out there that provide an umbrella, so to speak, of software that protects, or rather manipulates all of the layer 3 technology to make sure that the messages went through to your smartphone, you get confirmation. You should look into these companies that provide that layer, because that's a good opportunity to coordinate all of these different services in the different layers. And then we get into layer 4, which is even a broader reach. We had an Amber Alert just the other day. It happened up in Aurelia. We're in Mississauga, and this type of technology is used to give a much more broader reach to situations for people to be on the lookout, or there might be some bad weather forming or whatever. So this is a level that's coming in possibly from municipal jurisdictions, federal jurisdictions, and things like that. So when we get into the code structure, basically these are the layers, and they all respond to each other, but the building code trumps all of the other codings down below. So we have the National Building Code, which is in harmony with the International Building Code, and they are going to dictate how to build a safe building in the particular region where the building is being constructed. These building codes, like the fire codes, are not in harmony across Canada. They have some regional influences, so you need to certainly check your local building codes and fire codes to make sure that you're actually following what is appropriate for the area you're designing into or installing. But the building code trumps every other code, and the government regulations, they form the style or the qualifications of these codes that the building code decides that they need. And under those are the life safety codes, and we can see that ULC S576, it falls in that life safety area. Then we have the fire code and the electric code. All products sold in Canada will follow under the electric code, so they will have some ULC for electrical safety. What we are talking about today is another level of ULC, and that is about the life safety code. So all TOA products do have ULC for electrical safety. However, we have the special ULC S576 listing for certain products. And by the way, there is no equivalent to the NFPA 72, which is the National Fire Protection Agency. Their codes for installing fire systems, fire alarming systems. And Chapter 24 deals with mass notification, its applications, installations, and performance. And unfortunately, we don't have the equivalent up here. And so what happens is when we're designing systems, we will look at what the building code asks for, what the fire code asks for, etc. And if it doesn't meet our particular needs, as best practices, Chapter 24, NFPA 72 would be referenced. There's no reason why you couldn't use some of the concepts there on how to install the products or how to apply the application, etc. So when we get into ULC S576, basically, the scope is going to be about products and devices and their specifications. So this is a product-based scope. It's not specifically about how M&S will work, etc. It's all about the products. So it's all about the connectivity and how the bits and pieces will work together, and how they will do the job when people have to use them, the communications for the first responders, how they'll use those facilities in order to get everybody into a safe situation. Now, what's not covered under this is the audible signaling devices. They have separate standards, the same with speakers and visible signaling devices. So 576 really just talks about the communications, the audio communications products, how they'll work, the priorities, the specifications, how much distortion we're going to allow in the amplifiers, how do we deal with battery backup, how much hang time you have on batteries, etc. So it's all about the equipment in this standard. It's a new standard, and unfortunately, as I mentioned before, it's not referenced in any code as yet. However, changes will come. My understanding is the building code is, generally they're in 5-year cycles, and they're coming up to a cycle change, possibly another year or two. And at that point, they're already looking at revisions, I'm sure, to apply 576 into the building code. And so what we'll see is down the road is when the building code is released, it probably will reflect some of the requirements that are asked for under S576. Of course, S576, if the product is listed, then it's possible to use that product connected to a fire system, a fire control panel, etc. And basically it defines the features and the processes that the equipment should have, the desirable features that would be inherent in a product that meets this listing. Now, 576 was harmonized as close as possible to the equivalent code down in the U.S., which was 2572, and it was released in 2011. So we're a little bit behind the U.S. The idea was that the coding, they wanted it to be as close as possible to what the U.S. has so that we're not building a bunch of different equipment for different regions. However, unfortunately, there were enough differences between what Canada needed and what the U.S. Has stated, and so there are some minor variances that we had to apply to our equipment in order to meet the Canadian standards. So basically, the idea of the UL S576 and the UL 2572 is basically to follow the intentions of the NFPA 72, and in most cases, Chapter 25. And if you can get your hands on a copy of NFPA 72, look over Chapter 25. That's where it's going to detail installation of mass notification. And also in the appendix, it talks about speech intelligibility, but unfortunately, it was left out of the body of the document, so it's just a suggestion that we have speech intelligibility in these voice systems. So basically, 576 is what we need to build. So some of the desirable features for products that meet the emergency communications and mass notification system protocol are the following. Now, the first three I put in italics because I've added these in. They are not addressed in the body of 576, but I think it's worth noting that emergency communications is not your standard PA systems that we have all installed in the past. They are systems that require a lot more knowledge, a lot more care in assembly, wiring, etc. So it's necessary to have a very good, reliable products. You can't be using, you know, really cheap product here. Well, I shouldn't say cheap, but questionable product. You should be picking this up from a reputable manufacturer, and certainly if the product is listed, they've gone through the scrutiny of all of the test procedures that are required by ULC. Redundancy, TOA believes in amplifier redundancy, and that is the power section of the amplifier. If anything is going to have a problem, it's something that's generating power. So we build redundancy into all of our emergency communication products. However, it's not a listed requirement for ULC. And continuous operation. Keep in mind that these systems are up and running for 24/7, and when called on, they have to be ready to perform. So again, that comes back to reliable products, not just some knockoff cheap products out there. So some of the things that are addressed are priorities, who's communicating when, who has the highest priorities and the lowest priorities, and when things will happen. Battery backup for Canada, this was one of the ones that was a bit of a tricky one. We have to have a 2-hour hang time on battery backup. It's a little bit different in the U.S. It's much less time. So that created us into a longer development cycle to get the requirements for the battery backup and doing 2 hours at the specifications. There's going to be performance specifications, as I mentioned, about harmonic distortions, etc. Fault tolerance, obviously we can't have one part of the system faulting and then taking down the rest of the system, so there has to be methods to provide care that one part of the failure doesn't bring down the system. Live and digital messaging is a requirement and is listed in the coding. Operation of fault logging and notification. Basically, you want to know from a day-to-day operation what has transpired, who's paging who, what has gone on, and if there are any faults, this needs to be logged. Connectivity to other systems, as an example, fire panels, etc., or if you have long runs of cabling out of the system, what needs to happen. Certainly monitoring and trouble signals. We need to know whether a system has faulted and to provide some sort of indication that there has been a problem. Endurance, this is obviously the product needs to last a certain length of time during a fault, or not a fault, but a situation, needs to survive a certain period of time. And supervision of access. This is discussed about the security for these sorts of products. So in a nutshell, that's basically what S576 is addressing. So if we look at the VM3000, again, this is the first in North America to have this UL S576 for Canada and UL 2572 for the U.S. So what is this? If you look at the complete system, the VM3000 is built up of two basic or main components, and that is the voice alarm amplifier, the VM3240 VA. And there's only one in a system, and that supports 6 zones. And then we can build up to many more zones by adding on the extension amplifiers. And each one of these extension amplifiers has 6 zones of capability. And so when you stack all this together, it has a total maximum zonage capability of up to 60 assignable speaker zone outputs. And of course, that's 10 units, 1 VA and 9 E amplifiers. There are also, when you stack these up to a maximum, there's 80 I/O control points for various operations, setting off strobes or initiating paging, etc., or doing other sorts of control I/O capabilities. It's capable of BGM to each of the zones under control. The mic line inputs on one of the VM3240Es, so there is at least one mic line input on the E version, and it has a full digital DSP audio mixing built into the unit itself. So you can see all the different capabilities. We've got BGM coming in. We got some paging microphones. We got a telephone capabilities, providing you add on some contact closure control, etc. And this is a general overview of a maximum system. So if we look at some of the features, we can have the first responders microphones and remote microphones. And please note that the RM300MF, the first responders microphones, are not currently listed. They are pending. We have some minor details to work out, mostly related to priorities and monitoring of the lines to them. But they should be available, and basically what they do is they emulate the front panel of the VA amplifier in its microphone, but this allows it to be run in a remote location. So we have up to 4 of these remote microphones in combinations. We have digital messaging built in. Now 2 of them are dedicated to alerts and evacuation, so 1 alert, 1 evacuation, and 6 general messages. And those general messages, if you use the VM3000 in a general use, could be used for just corporate announcements, possibly, clean up on aisle 3 if it's used in the grocery store, that sort of thing. You can use them for whatever you want. You can record any messages you want into these. They are user definable. All of the settings are set up through PC software. You can set up some of the capabilities through the front panel, but most of it's done through the software, which is very easy to use. So you can set up the zone setting, the priority settings, the monitoring for failures, etc. And the front panel of the unit has an LCD display, and that allows you to take a look at currently the status of the system and for some configuration settings if required. The software, it's TCP/IP connectivity. There's software panels for setting up the system, doing the monitoring or surveillance, setting priorities of zones, events, and logging capabilities. Now, once it's set up, a computer is not required. It will run as a standalone unit. Once it's programmed, you can basically take away the computer. For emergency functions, we have continuous speaker line monitoring. It does not interrupt any background distribution of music or paging announcements. And we can monitor for opens and shorts and earth faults. And this is using an impedance method. This was approved by ULC as a viable means of detecting whether your speaker lines are viable or not. We have complete fault detection and indication on the VA amplifier and on the extension amplifier. The EV is the digital messaging. We will know that if there's a problem with any of the digital messaging. For battery backup, it's monitored. The charging system for the batteries are monitored. Any sort of emergency control that's actuated is monitored, and the AC power is also scrutinized. You can do off-site log and air check. Has the capabilities to do this via LAN or WAN, so you can dial in and retrieve the log files and check if there's been any errors, etc. We have for the microphones, the remote microphones, we have 2 ports that are available that allow up to 4 of those microphones to be attached. And the two-phased voice alarm digital messaging, which is the alert and the evacuation broadcasting, is capable with the VM3000. So you might set off an alert first to tell people that we're investigating a situation, and then if it's determined that there is a problem, it can be elevated to the next level, which is the voice evacuation, and the digital messaging will relate to that situation to evacuate the building. Any of the emergency voice communications in the system must be done through the front panel microphone. This is a monitored microphone. If it's disconnected from the front panel, an alarm will be set off. The other microphones, the remote microphones, are not to be used for any emergency broadcasting, just general paging. So for general paging, we have the two lines as suggested before for setting up the remote microphones, the RM200s. And we can do all zones, groups, and individual. This is a very flexible paging matrix that's available to the user of the VM3000. There's up to 99 groups built into the paging matrix. You can do any combinations of single zones or multiple zones or groups or what have you. This can also trigger the voice page, or it can also trigger the digital messaging if so desired. Okay, and we can also do the background music uninterrupted, but you'd have to add in a secondary amplifier. Basically, the way the VM3000 works is each one of the amplifiers, whether it's a VA or an E, has a single internal amplifier of 240 watts, and it's feeding a relay bank. So normally, by default, it's the amplifier is feeding the background outputs to the zones, and when there's a page, the relay will flip across to the paging side, in which case all of the background music in all the zones will stop, even though the page isn't going into that zone. So in order to get around this, if desired, a secondary amplifier is used to host the background music, and it will be full-time online, and when you page, only the background music will stop in the zone that you page in. This is very similar to, if you're familiar with the SS9001 or the SS9012 relay bank, where it has two inputs and multiple outputs, and it requires two amplifiers to support uninterrupted background music. Also, the VP2241 is also used for redundancy. As I mentioned before, we believe that if there's going to be a weak link, it's going to be a power amplifier, and it's best practices to have a backup amplifier that will kick in should there be a fault on the main power amplifier. We've gone over most of this. The front panel mic, again, is going to be used for emergency use. That is the only microphone that can be used for emergency purposes. 240 watts spread over the six speaker outputs. So keep that in mind when you're designing a system, that 240 watts, if it's feeding 6 zones or any number of zones, that you have 240 watts available to you, and you need to total up exactly how many watts or what your load is for that entire amplifier. So you need not to exceed the 240 watts that the amplifier can put out. If you have to go over that, it's easy enough to use an extender amplifier and share that power. Even though you're feeding into similar zones, you may not be using 12 zones, you may only use a couple of zones, but you need all of that power. You can certainly steer the page to the various amplifiers to feed the same general area, but having all that wattage available to you. There's XLR inputs for paging or mic line use. a couple of BGM inputs that are selectable, so you can have a music source A or B, or one or the other. There's a record out should you want to record all of the paging information that's being broadcast. Each of the VA amplifier itself has 8 general control inputs and outputs, and these can be used for setting off strobes or sirens. It can be used to initiate paging or just about anything. It can be mapped to any particular paging scenario. An example might be if you have a warehouse that's noisy and you want to do a page into that warehouse, you might want to set off a strobe to indicate that a page is coming through, and that will have people either shut down the machinery or go to an area where they can hear the page and proceed to get the instructions. The emergency control outputs, they are to stop and start the alert, stop and start the emergency, reset the system, and mute the VM3000 should it be necessary to silence the system because there's some higher level of priority coming through, possibly from a fire panel or etc. You can totally mute the VM3000 system. Status out, these are handshakes that could be sent off to a fire panel. Since it is a CPU-based product, there's always the possibility that the internal CPU may fail, so that's alerted. If there's any other sorts of failure in the system, there's a status out for that, and of course, if the VM3000 is put into emergency mode, any other connected appliance will certainly receive that condition should it be connected. Now, talking about the CPU failure, one interesting thing about the VM3000, should the CPU fail, it will fall back into a very simple analog mode. So you will lose the DSP features, but your message will still get through. It bypasses all of the technology and basically takes you down to a very simple low-level analog amplifier. So there will not be a complete failure of that system. Now the VM3000 system does run on AC mains primary power, but it also has the capability of being run for 24-volt DC power for battery backup, etc. You can run the VM3000 system off the AC mains on a certified UPS backup power should you want to go that route instead of the battery backup. It depends on the situation, but certainly battery backup or UPS on the primary is possible for the system should there be a power failure. And of course the computer connection for programming and monitoring. The VM3240E, which is the extension amplifier, which allows us to extend up to 60 zones, all the same features. The only thing missing really here is the extra mic inputs and the BGM inputs and the record output. Pretty much everything else stays the same. There is still one mic line input, so that could be used for a local broadcast to that unit, or you could put in another audio source such as a BGM, etc. The remote microphones, again, only used for general paging, not to be used for emergency paging. The RM200M has a 10-zone selection for paging and messaging, so you can pick up whichever combination of matrixing has been done in the software. So a single button may call a single zone, or it may call multiple zone, depending on how the software is set up. It can also be used to trigger the digital messaging. You can punch in the buttons in any combination, and once you hit the push to talk, you're going to output to those particular zones. There's LED indication for the zone selected, and also as busy indicators, because there might be multiple units in the system, and somebody might be paging into a zone, and a person might need to know that my message is not going to go through to that zone because it's busy elsewhere. So that is built into these devices. There's also a fault LED indicator that's basically monitoring the condition of the VM3000 should there be a failure. The operator at this point will see that indicated and know that some attendance must be done to the VM3000. Now, any connection over 20 feet, and this is part of the ULC coding, and these fall particularly into this, long runs have the ability to pick up transient spikes, and it's necessary to suppress those. So we don't have this built into the VM3000 or the RM200. So a Cat5 UL listed transient suppression device must be used should these microphones be used more than 20 feet away from the main VM amplifier. So keep that in mind. The extensions, the RM210 extensions, allow you to build out to a much larger system. You can get 4 of these added on. That gives us 50 zones or 50 selections capable with the combination of RMs and 200s and the RM210s. As mentioned before, the RM300MS currently is not listed. It's going to be pending, but basically all it's doing is emulating the front panel of the VA microphone. So once these are listed, you'll be able to remotely locate these in an area that makes sense when dealing with first responders. They don't necessarily have to go to the VM amplifier that might, be close to the fire panel, but might not be exactly where the first responder would gravitate to. So this could be put into a very obvious location for use as a microphone to communicate to the occupants. And of course we have the extenders here. Again, we can max these out by adding 4 more in. These have the same zoning and status indicators available to us, but this also has, you can program these for individual faults, not just a general fault, but they can be mapped to specific faults that might be coming from the system based on the I/O that's being triggered. Okay. Some other additional products are available. The 24-volt DC power supply. It's AC mains connected. It's our 24-volt DC power for the rest of the system. It is used to charge batteries via the VX2000DS, which manages all the low voltage 24-volt power to the rest of the system. When it's switched over onto the battery side. It also charges the batteries, monitors the batteries for temperature overage, etc., and monitoring to make sure that the power levels are maintained, they're not undercharged or overcharged, etc. And we mentioned before, the VP2241 is a 24-volt DC power amplifier, and that is used for the uninterrupted BGM support and also for redundancy, and it's the 240 watts. Also, we have speakers that have been UL 1480 listed. Now, the 1480 is the U.S. coding. Up here in Canada, it's a ULC S576. And these can be used for fire signaling, and the UL 2043 is for plenum use. So some of the products can be used in plenum. They have the back boxes, and they're rated for plenum use. We have the recently introduced PE series of speakers that are 1480, and just recently we released the SC630 TU, which is UL 1480 or S541 for signaling for emergency situations. So there's a few possible selections here, whether it's in the ceiling, whether it's hanging down from the ceiling, or whether it's a paging horn style, surface mount type speaker, etc. So typical applications, we've done a lot of correctional facilities, some warehousing, manufacturing, educational institutions. We've networked these together using the NX100. I'll talk briefly about that shortly. But it has a wide range of possibilities, and if you want to go and see where this particular product has been installed, please visit our website under installations, and you'll see all of the places where the VM3000 is currently installed, and it's growing by the day. So the VM3000 was originally designed or conceptualized for small to medium facilities. It's not in itself a networked device like the SX2000 system, which is a CobraNet multi-building type of product, a distributed system. This is meant to all be installed in one rack in one building, and then the speaker lines are distributed throughout the facility. It certainly can be used for non-emergency situations and applications. It's a wonderful multi-zone PA system with the digital messaging that could be used for corporate tagging or retail use or what have you, whatever you can envision for those digital messaging. But when it comes to emergency communications, obviously the nursing homes and the educational facilities, transportations, and even in the community-wide area alerts. We have one installation out east where it's being used to warn of bad weather conditions. It's a small community, and several of these are configured as nodes, and the phone system is used to dial into them and to alert of pending weather conditions. Can be done through a phone system. It can be done through our NX100, as you'll see shortly. So, typical applications, it's pretty easy to do. We have many zones. A typical educational system might have all of these separate zones that need to be paged into. You got the interiors, you got the exteriors, you got the special purpose areas, such as assembly halls or whatever. I would recommend that if you're doing as an example, a gymnasium, that is a separate system that you put in a performance PA or what have you into a gymnasium, and then maybe put a couple of paging horns in there that are just for paging, and keep it separate from the performance system, because you want to make sure that any critical paging that goes into these areas that you might think you would use the VM3000 for the performance side, you'll want to make sure that it's always on. There's always a chance that somebody's going to turn off a performance PA, and if you think you're going to page into that, well, guess what? It's not turned on. So my suggestion would be to install your normal PA into those places that might require a separate system, and then just install some paging horns in there just to get the critical messaging through. Of course, you want to send down a contact closure to mute the performance PA so that critical paging will get through, and the performance PA will be muted so the page can be heard. Grocery stores, for sure. You can have cash register, microphones. You can page into, a price check or clean up on aisle 3. The digital messaging could be used for some, sales features, etc. If there's attenuators in the certain areas, they can be overridden, so any messaging, paging will come through, and just the BGM will get through at the level set by the occupants. However, the paging would come through and override the attenuators. That's an important consideration. But certainly any of these systems can be parked up to a fire panel. They don't have to be standalone. I'm just showing you some simple uses of the product for general use, but certainly can be worked in with fire systems. Hotel, again, many floors, many zones, a typical multi-zone system. We get into multi-story buildings. I mean, it's basically a multi-zone amplifier system with paging. So here we get into a concept that we've put together where university campuses, college campuses tend to be many buildings separated geographically. And basically you would put VM3000 system in each building and then network them together with the NX100. And this would transport over dedicated LAN or through the WAN to the various buildings any critical paging from the administration. Each building can run independently. They can have the RM microphones in those buildings or just a single dedicated emergency microphone if they want to keep it simple. But it is possible to network the VM3000s. It doesn't do it by itself. You need to add in the extra NX100 appliance to do this. When we get into installing into fire panels, as I mentioned, there are some considerations. This is not just general PA. There's some rules to follow. If you look into the VM3000 manual, there's 2 pages that describe specific wiring conditions and certain protocols that must be followed when installing to a fire panel, and I'll go over those briefly here. So your FACP, which is a fire alarm control panel, you can see that we can connect to that from the VM system. And basically the handshake going back and forth is if the VM system is active and doing a page, emergency nature or whatever, the fire alarm panel is going to know that. They're going to get an indication. If there's a fault from the VM, it's going to send it off to the fire alarm panel. Now back the other way, the fire alarm panel, should it fault or be active, or if there's a power supply, a UPS failure or AC failure, that's going to come back to the VM system, so that now each system is talking back and forth. It understands what capabilities are existing, what's the status of the 2 systems. This is just one example. There's other routines that you can do, but this is just a bare minimum typical example of how you'd hook this up. And if you look at the FACP, you'll see that the lines coming back in to our system, they are monitored lines, so that if there's a problem on those lines, you can set it up in the software to note the faults and that it needs to be investigated, that there's something has gone wrong with that particular control line. Now when we get into remote notification devices or appliances such as a strobe or a siren, they are generally more than 20 feet away, so they are going to have to be monitored separately. And these are generally will be put on a notification appliance circuit, and these circuits will monitor the condition of the communications back and forth, so that if there's a fault with the device itself, the NAC, it's going to send a control signal back to say, well, you know, whatever you have attached to the NAC is not going to work, so you need to attend to it. This is to allow remote connection to devices such as strobes and sirens, and to make sure that the signaling has reached its destination and that it's all monitored. Some considerations for installations for the VM. Must be installed in a secure rack. The VM3000 comes to you out of the box as a secure level 0. It has no security except for the password. So you'll have to build it into a secure rack. And a secure rack at a level 1 is simply a lock and key. It has to be installed in a controlled access area, which is level 1 again. Authorized personnel only under lock and key. All the control lines associated with the VM, and that is the link cables, etc., and the status cables, the control cables, if they're inside the rack, they're fine. They don't need anything special. However, should the cabling need to be extended more than 20 feet, They need to be in conduit, and they need to be protected from any sort of breakage, etc. So it's necessary to run these in EMT. Of course, you're going to need a listed equipment rack. You can't put this stuff in a wooden rack, as say. It needs to be in a rack approved for typical communications associated with emergency communication. At the very end, the PA system itself of EM could be installed by the AV integrator, paying attention to the rules set into the guidelines that come with the product on the first couple of pages, I think page 6 and 7 of our manual. They follow those guidelines, have it installed, and have it inspected. The audio integrator certainly can put that side of it in. But when it comes to actually hooking up to the fire panel, at this point you need to discuss with the qualified fire tech exactly what the connections are, what's the protocols, who's talking to what, and what's the priorities associated with who's doing what when. It is necessary to understand the priorities because it's possible in some circumstances where the mass notification system will have a higher priority than the fire, but generally fire is higher than mass notifications. And we'll look at that now. The building code dictates basically what fire alarm system is employed, and that's based on height, occupancy, and the use of the system. Generally, a small building, low occupancy is a stage 1. There's going to be an alarm go off and everybody leaves the building and that's it. But when we get into larger buildings, many more people, it's very complex to evacuate the building. You get into the 2-stage alarm systems, and these require voice communications. That's built into the building code. And basically it's going to be an alert and then an alarm. And the alarm is going to be evacuate the building. Alert is going to be we're investigating, that sort of thing. And that's when the VM3000 will come into play. It becomes a voice side of the communications to the occupants. It's the one-way PA that we discussed earlier on in the webinar. So the signal priorities, when it comes to the voice side, live voice always takes precedence over any other signal in the system. So the highest level is an actual person giving directions, and of course these have to be people with authority, people who know what they're doing, not just somebody grabbing a microphone. This is emergency use. So it's going to be somebody in authority, somebody knows what they're doing. They're going to have the highest priority should other alarms and that be turned off. A voice communication is going to be your highest priority. Emergency automated voice, in other words, text-to-speech, and this is a technology that's in use. That is a lower priority, but it is still a person typing in a message, so it's going to have a higher priority than any sort of alarm or digital messaging because there's a person involved. And then comes the alarm signaling and digital messaging, and then, of course, any other signal that might be associated with the system, faults or whatever, that is your lowest priority. So when we get into the fire panel, normally the fire panel will always have the highest level of priority, and it'll be over the mass notification systems. However, there may be a case, and it's up to the authority having jurisdiction, the AHJ, based on a risk assessment, may mandate that the mass notification system will have a higher priority. Situation comes to mind where you might be dealing with a company that handles dangerous chemicals, and that's more likely to be a priority than a fire in the building. So it's necessary to have that voice communication alert that there is a situation. We need to evacuate the building. Based on the chemical spill, we need to hunker down into a safe area, and sometimes we need to warn the people outside the building in a more wide area response to the surrounding neighborhood, etc. So there are times, and depending on the AHJ, to determine which system has the highest priority. Now, the M&S system can now take over a fire alarm situation. Before, my understanding is that a voice communication had a very brief lifespan in a fire alarm situation. In other words, the voice system could be used one time only and for about 30 seconds and never used again. That has all changed. Now the voice system can be used full time as long as the fire panel is notified that the voice system has taken control. And the last point here is that, of course, there has to be some capability to manually override that should be necessary to relinquish control back to the fire panel. So somewhere in the system, a manual release has to be built in. Also, the fire strobes, they will always remain on. Even though we have a voice priority capabilities, the strobing system must always be active regardless of whether the voice alarm system is in play or not. And should the voice system be inactive but still keyed and still in the system, it's necessary to send out an audible every 30 seconds. That's part of the coding, so that people know that the M&S system is still in play, and that you know, there is still an issue, because the M&S system will mute the alarms that are coming from the fire system so that the messaging can be heard. So it will get silent except for the voice communication, and every 30 seconds this tone will have to come through should there be no active messaging. Of course, both systems, the FACP and M&S, provide active notification to each other, whether if it's in operation or whether there's any sorts of failures. So in closing, I want to mention that TOA has been a world leader in manufacturing these types of products. Certainly the first in Europe and in North America with systems that are listed for emergency communication purposes, and that the influence for mass notifications has been increasing over time because of politics and security and climate changes. This is a very strong growth market for our business and for integrators, and there's going to be a lot of retrofits coming down the road when the stakeholders decide that, geez, we better do something because of all of the liabilities that might be associated with, and that now that we know that these systems are in place, maybe we should deploy them, etc. And so it's a good time to pay attention to the coding and the disciplines that are associated with emergency communications, because they're going to obviously respond to all of the changes in the situation out there now with as what we've discussed before, security, etc. And again, the AHJ will determine what is required to protect the stakeholders. They have the final say on how much will be deployed, and they will manage the situation and to make sure that what is deployed will suit the requirements. And the S576 was developed to help equipment manufacturers design the products, and also defines the types of equipment that are used for emergency communications. Keep in mind the VM3000 can be used for general use and also emergency communications. We can connect to a fire panel, and by all means, please consult your code experts in your regional areas where you're deploying these products. It does change from region to region. The building codes are not consistent across Canada. Fire codings are slightly different, may be enforced differently in different areas.